Hi geometry students, you are watching lesson 6 guided notes videos for unit 7. Still talking about volume, just changing the shape up again. We are talking about spheres today. So in your notes on page 143, there's a place where you could follow along too. So the sphere is technically the set of all points that are the same distance from the center. So if this one's like coming towards you and this one's even closer towards you, you'd end up getting a sphere out of that. The radius functions the same as the radius of a circle, so center to the edge, but now we're talking the edge of the sphere. And if you're going through the center with both endpoints on the sphere, you're still a diameter. Now, it's very important to talk about the center of the sphere though, because you technically have other circles that exist. You'd have a center of another circle, but this is not the radius of the sphere. So that's why we do need to go through that definition. The volume formula for a sphere, I personally have absolutely no idea why it is what it is. I feel like I've looked it up once before. Didn't make sense, but this is what it is. Here's how we're going to use it. This would be a fantastic time to get your calculator out and learn how to use it for this, because we got fractions, we got pi, and we have a number being raised to the third power, which could be really different for your calculator. So for example, on this problem, they're giving us the distance from one edge of the sphere to the other edge, which means this is the diameter. If the whole distance is 18 millimeters, and I only want from the center to the edge, I only want the radius, then I'm just going to take half of that. So I'm going to be putting in my calculator 4/3 pi times 9 being cubed. Different calculators are different. Now, unfortunately, while I'm stuck at my house, the only calculator I have, is this graphing calculator. So I can show you how graphing calculators work, but every calculator is different. You're probably going to want to just use Google and figure out how to do to the third power on your calculator. So I'm going to do 4/3. My calculator can't handle pi, so I'm not going to put pi in, but 9 to the, that's not the 3 button, to the third power. This caret button, little mountaintop, is how you say I would need an exponent to the third power. So 972. Now you'll notice I didn't put pi, because on this calculator, when you would type in pi times 9 to the third power, it gives you the decimal approximation. So in terms of pi answer, I'm going to have 972 pi. The nearest whole number, I would take this 3050, the 6 rounds it up to a 4. So that's what I'm going to put on those two lines. Let's go back to where we were. So in terms of pi again was 972 pi cubic millimeters. And once we multiply by pi, I said 3054 cubic millimeters. The nice thing for you is there is very few ways for us to make this complicated. There's not like, oh, I can make you do sine, cosine, or tangent. Like, it's literally, if you have the radius, you're good to go. Sometimes it's hard to picture what we're trying to find the volume of. So this is some of those. We're going to rotate this image. Now, a couple things. Pretend that this semicircle actually goes all the way to the 4. So it's kind of poorly drawn, but pretend it was. We're going to reflect it first over the y-axis, which means it would look kind of like this, only more circular. But I'm not just doing a reflection. So this dot, which is at the 4, ends up at the 4, but it would be spinning in front of my screen and behind my screen. You get a sphere, which means the only thing we need to find its volume is the radius. So we just need to cube the number that represents the distance from the center to the edge. That's the one that I told you we need to pretend is actually at 4. It's kind of poorly drawn. It looks more like 4 if you go from center straight up. That looks like 4. but whatever. Now, a lot of times you're going to get fractional answers here because this is saying here that I'll have to divide by 3, and not a lot of numbers are divisible by 3. So I'm going to go to my calculator. I'm not going to type in pi. I'm going to do 4/3 times 4 to the third. I don't want the calculator's answer of 85.33333333333333 because we don't mix decimals with pi. I can change mine to a fraction because I know how my calculator works, and I get 256 over 3. So if your calculator says 85 1/3, you're closer, but we also don't use mixed numbers within terms of pi. This is the version we'd want. So you could keep the fraction in front of the pi, or you could put the pi in the numerator, 256 pi over 3. Except I literally just now read the directions, and it didn't want in terms of pi anyway. It said whole number. So if I want whole number, I'm actually going to go ahead and multiply by pi. So it's still not that 85. I need to multiply by pi. So the correct answer for this one is actually 268. It said 0.0. This 0 makes the 8 stay the same. So about 268 cubic units. Part B is really similar. It's the exact same shape, but now we're going to revolve it over the x-axis. The interesting thing here is this point, which is 4 away from the x-axis, would go 4 below the x-axis and lands on the same image. This would be one of those reflectionally symmetric pictures. Everything lands on itself. So here, when I rotated it over, it landed on blank space that nothing was labeled on. Here, it lands on itself. But you're still going to picture it coming out of my screen and behind the screen. So you don't actually have a sphere. You have half of a sphere, which hopefully in geography you've talked about the fact that that's called a hemisphere. So for the volume formula, you don't have the whole sphere. You don't have all of 4/3 pi r cubed. You have half of it. So it's the exact same work we just did, where we figured out the radius was 4 units, but you're going to take half the answer. Now, because this time I'm reading directions, I'm not going to bother stopping at the in terms of pi answer. I'm going to type in 1/2 times 4/3 times pi times 4 to the third power. If you really can't find the to the third power and you're too lazy to Google, do times 4 times 4 times 4. For most of what you need, that'll be a decent workaround. And I'm seeing 134.0, so it's about 134 cubic units, which should make sense to us. If this is about 268, then half of that will be about 134. Half of 268 is 134. The only time this kind of doesn't work so easily, especially if you can't find some of the buttons on your calculator, is when we ask you to work backwards. When we tell you the volume and we ask for some other portion of the shape. Every time we say, hey, this is the volume, go ahead and use that volume formula. So I'm going to come over here and try and use some of my space. I'm going to go ahead and write down 4/3 pi r cubed. But this time, I know the answer to the volume. If the radius has been plugged in, 288 pi is spit out for the volume. So in this volume spot goes 288 pi. That is equal to 4/3 pi r cubed. So I need to solve this. Lots of different ways you can start this. Let's go ahead and say I hate fractions. I don't want over 3 anymore. The opposite way to get rid of clearing out your fractions, the opposite of dividing by 3, is to multiply by 3. So I'm going to multiply both the left and the right by 3. So 288 pi times 3 is 864 pi. Now remember, the whole reason we did this is to make this go away. So the 4 is still there, the pi is still there, the r to the third is still there, but that's it. I'm now going to divide both sides by 4 pi. If you do that in your calculator, be very careful how you type it in. It's much easier just to say, hey look, pi cancels itself out. All I need is the 864 divided by 4. And if I do that, I get 216. Now this is not square root. This is square root would not fix this problem because we don't have squared. We have cubed. We need something called the cube root. It's like square root, but we're asking ourselves what number times itself 3 times gets us 216. There's a function on your calculator for cube root. Yet again, I can only show graphing calculator people where that is. So if you have a graphing calculator, you need to push the math button. And then you're going to see not only the cubed, but right under it, the cube root. So I'm going to type in the cube root of 216. 6. So when I take the cube root of both sides, I get r is equal to 6. Now, some of your calculators, you won't be able to see this actual cube root, but you will see an x root. So if you push the 3 button first, then your x root button, and then type in your 216, it should spit out 6. But remember, this is the radius. I don't want the radius. I want the diameter. So if in this sphere the radius is 6, then its diameter would just be double that amount. 12 inches is the final answer for this problem. Number 4, Saul wants to design a spherical oil tank that can hold 64 pints of oil. Pints is not typically something that we will have you calculate in, but we can figure out things. We can still solve for something like the radius because we can do conversions. Every time you have a pint, you get about almost 29 cubic inches, in this case of oil. So let's figure out then how many cubic inches we have, because we just did some work with cubic inches. So I'm going to do conversion. I'm hoping in science classes you're familiar with putting your number over 1 and multiplying it so that the value goes away. I don't want pints, but I do want cubic inches. So we are told that 28.875 cubic inches is the same thing as 1 pint. So I need to take 64 times 28.875. This is the same thing as 1,848 cubic inches. And we just did a problem where if we know the cubic inches, we can find the radius. So that's what we're going to do. I'm going to go to my volume formula, 4/3 pi r cubed. I know my volume. And we're going to solve for the radius. I'm going to do the same thing as before. I'm going to multiply by that 3 because I would like to get that out of the way as soon as possible. So 5, 5, 4, 4. But here's where it's slightly different. If you remember the last problem, the next step I did here was I divided by 4 pi. And it was really nice because it just canceled on this side. That doesn't happen here. If I would divide by, don't write this down if you are. If I divide by 4 pi right now, I have to be super careful in my calculator because there's nothing to cross out. That doesn't happen here. So I'm actually just not going to do that. I'm just going to divide by 4 first. And when I do that, I get 1386 equaling pi r cubed. Because if you divide by pi, or when, because we will eventually have to divide by pi, yes, it cancels on the right, but it absolutely doesn't on the left. If you type that in your calculator, you're going to get terrible decimal that starts with 441. I don't want that. I would like to round at the very last minute, so I need to think about the fact that I have something set equal to the thing I want to the 3rd power. So the only thing stopping me from having this answer is this to the 3rd power. So I'm just going to get rid of it. The opposite of cubing something is to cube root it. So I'm going to cube root that fraction of 1368 over pi. So let me show you how I'm going to do that on my calculator. So I need the cube root, which remember on graphing calculators is math, and then the number 4. Some of your calculators, if you see this x root, a lot of calculators have that. Let me kind of go through that. A lot of calculators, wherever you find the caret key, if you push shift and then caret, you'll get that. But you'll have to push the 3 first and then that x root. So I could do that on this calculator as well. It's just telling my calculator, oh, I want the cube root. But we're supposed to be finding the cube root of, I forgot that number, 1386 over pi. So 1386 divided by pi. Now is when I want the decimal, not a second before. So the directions on this one, I'm on the wrong page. No, I got it here. The directions say to the nearest tenth. So that just means that 6 is in the tenths place. The 1 will make it stay the same. We're just going to use 7.6. So the radius to the nearest tenth is 7.6 inches. Those are pretty much the 3 things that we'll ever ask you to do. Volume, make sure you watch in terms of pi or rounded. Revolving it, sometimes it's a sphere, sometimes it's a hemisphere. And hey, I'm going to tell you the volume, go backwards and tell me what the radius or the diameter, or find something else. Or word problems, heaven forbid we have to read. Number 5, if you turn the page, we're going to find the volume of this. It looks like a pill capsule, but that would be a huge pill capsule. What I want to point out, it's a composite figure. We have a hemisphere here at the top. Plus in the middle, we have a cylinder. Plus at the bottom, we have another hemisphere. If they're all being glued together, we will be adding their volumes. So I'm just going to put in my formulas. 4/3 pi r cubed, pi r squared h. Ooh, I made a mistake. I just wrote down the sphere formulas, but I said these were hemispheres, which means this should technically have a half. This should have a half. So I'm just going to go find these numbers. In this hemisphere, 6 is this entire length, which means they're telling us the diameter, which means the radius would just be half of it. So into the 1/2 4/3 pi r cubed, my r will just be a 3. And the cylinder, it's the exact same circular base, so I'm still going to use the 3 for my radius. But I will need the height. Be careful with this one. I want the height of the cylinder. 21 is not the height of the cylinder. 21 starts at the very end of the hemisphere and goes to the very other end, which is not what the cylinder is. So what I need to think is, okay, I need to chop off this much of it. How much is that much? Well, it's the distance from the top to the beginning of the cylinder. The definition of from the edge of the sphere to the center of the sphere is the radius, which means that amount that I don't know is 3 centimeters. It's going to be the same thing down here because I need to get rid of this portion of it, which is the distance from center to edge, which is still 3 centimeters because those bases are the same in the cylinder. So that means this height that we're trying to find is the whole length minus the 3 centimeter radius on top minus the 3 centimeter radius on bottom, which gets me 15. And then I have the bottom hemisphere, just need the radius. We already said the radius was 3. So it says terms of pi and nearest hundredth. So what I'm going to do in my calculator, I'm going to type in everything I see except for these pi's, and I'm going to let it do all the combining like terms for me because I'm lazy and I don't want to do that work myself. So I'm going to have 1/2 4/3, I'm not going to type in pi, but 3 to the third plus, oh, I just realized I put the squared inside the parentheses, and it definitely should have gone outside. I need to make sure I square that 3. So I'm going to add on 3 squared times 15 plus another 1/2, 4/3, 3 to the 3rd power. That just gave me 171, but remember, that was the pi's. I haven't told my calculator pi exists. So 171 pi centimeters cubed is one of the answers. Now when I actually type that times pi, I'm seeing 537, so that's nearest whole number. 2 is in the tenths place. 1 is in the hundredths place. There's a 2 in the thousandths, which means if I'm trying to round to the 100th place, this 2 makes it stay the same. So my other answer is approximately 537.21 cubic centimeters. Next word problem, because we got a bunch. In your job, you're making bowling balls, and you're going to see how much plastic resin has been used this week to mold them. Each bowling ball is a sphere. We're told the radius. We don't have to care about the finger holes because they're going to be drilled out later. And we are making 1,200 bowling balls this week, and pretending that nothing gets wasted, how many cubic feet were used in this machine. So I'm going to use this part here. Bowling balls are spheres, so 4/3 pi r cubed. And it says the radius is 4 inches, so I don't even have to take half of it. It is the radius. However, I was just going to leave this until the end, but it'll make our calculations a little bit nicer. The question wasn't about cubic inches, which is what I'm about to get an answer in. It's cubic feet, which means it would... Does that get easier? I'm trying to think of the best way to explain this, because there's a couple different ways you could choose to do this. Let's go ahead and do the conversion now. Not that it's easier. Doesn't make your answer any nicer, honestly. But whatever, we're going to do it anyway. Again, I'm converting. I don't want inches. I want feet in the end. So I'm going to get rid of inches to be left in feet. And I know 1 foot up is made up of 12 inches. Since the 4 is on top and the 12 is on bottom, I actually have to divide. So that's 1/3 of a foot for the radius. So I'm really going to be doing 4/3 times pi times 1/3 to the 3rd power, which is a little weird. This again is the volume of a single bowling ball. And when I make my calculator give me the fraction answer, it spits out 4/81. And remember, that's without typing in pi. This again for 1 ball. This company did not just make one, they made 1,200 bowling balls. So every time we make 1 ball, it takes up this much of the resin. So we just need to say, okay, if I need 1,200 of them, then I'm going to take the volume of a single bowling ball times 1,200. So if I take that times 1,200, finally my answer is, ooh, that doesn't get nicer. I was wrong. This answer is unpleasant no matter how you do it. You'd get this fraction instead, still with the pi. They don't ask for rounding, so technically speaking, the best answer is 1,627 pi cubic feet. However, that's not a super realistic, reasonable, helpful answer, so I'm going to go ahead and say that's also approximately about 186 cubic feet. That probably should have had rounding rules. Okay, number 7. A spherical tank with a radius of 4 feet. Why isn't this working? So I have my radius of 4 feet. Now it's not a circle, remember, I'm supposed to be drawing a sphere. Is an 1/8 full of water. So somebody went to fill this up and it's only an 1/8 full. I'm trying to find the volume of the water needed to fill the tank. So if I just talk about, let's talk about just the volume of the water that's currently there. Actually, no, I lied. Let's find the volume of the tank, the whole thing. So I'm going to pretend it's 100% empty. The whole tank is a sphere, which is 4/3 pi r cubed. I was given the radius. There's a lot of radii of 4 in this note set. Not really sure why. So not a coincidence, not surprising. We get the same answer I've gotten a couple times, the 85.333, which is the 256 pi over 3. That's not a 6. 256 pi over 3, or 256 over 3 pi. Now again, that's the whole tank. If it's 1/8 full of water, then I want to know, well, how much is left to fill up the rest? So I know nobody likes fractions, but think about it for a second. If I filled it 1/8 of the way full, I still have some left over. So if 1 of the 8 is in here, how many of the 8 is left? 7 of the 8s. That's how much it takes to do the whole thing. So I need, if this is the whole tank, then the volume what's left would be 7/8 of the whole thing. And the whole thing was that fraction. So I'm just going to take that number that I found earlier, times 7/8. Yet again, no rounding directions. 224 pi over 3. Or you can go ahead and get the approximate answer if it asked. And let's say this was to the nearest tenth. You would get 234.6-ish cubic feet. Carrie has 2 glasses. One is a hemisphere. They're just basically reading you words for what this picture already gives us. Yes, it gives us the fractions, but honestly, 1/4 is a pretty nice fraction in terms of a decimal. If you want to deal with this as 1.25 for your calculations, that's fine, but keep in mind, cylinders involve volume formulas with pies, so that means you will not ever mix a decimal with pi, so we might run into that in a second. First, though, I don't need to care about that. I just want the volume of the hemispherical glass. Not the first hemisphere we've worked with. Hemispheres are half of a sphere, so half of 4/3 pi r cubed. The radius is labeled, it's 2 inches. So I want half of 4/3 pi 2 inches cubed. Excuse me. So if I put that in my calculator, it says round to the nearest hundredth, so I don't need to stop at the answer of 16 pi over 3. I'm going to go ahead and multiply by that pi and get my decimal. My calculator says 16.755 and some other numbers, but it says hundredth. This first 5 is in the hundredths place, so the 5 after it makes it round up. 16.76 cubic inches. If the cylindrical glass can hold twice as much water as the hemispherical glass, what's the height? Because they didn't tell us how tall that thing was. We can solve for it, though, because they're essentially giving us the volume. Twice as much water as the hemispherical glass. So I'm going to double what we just got, which is unfortunate that we had you round that. I'm going to double this, which, keep in mind, doubling something that has half on it just means cancel that out. So I'm going to double the hemisphere. And I'm using this formula again because we shouldn't round until we're done with the problem. And we already rounded, and I don't want that. This is the volume of the cylinder. Cylinder's volume was pi r squared times h, where the radius is this 1.25. So I'm going to combine some things. This cancels out. 2 times 1/2 is 1. I don't need to write that. I'm going to go ahead and keep the 4/3 pi. I'm going to go ahead and I'm going to go ahead and cube my 2 and get 8. I'm going to go ahead and square my 1.25. And now I have to solve for my height. So it looks a little unpleasant, but it actually isn't too bad, especially because at bare minimum we got pies on both sides. Let's get rid of those. So that's something. Really then, to get h by itself, I just need to divide by that 1.5625. Here comes a kid to interrupt me. Eloise, I'm in the closet. What do you need? So the opposite of multiplying is dividing. What's up,
Where's
Sweepy?
Ben?
Ben's taking a nap. What'd you need?
What? And where?
In his room. He went down and laid down by himself. Apparently he was tired. I'm doing something for my class. Did you need something?
Can I please paint now?
You have to wait a little bit. I'm still working on this thing
Or
for
can
my
I
class.
please show you something?
I'm
in
literally,
the room?
Eloise.
Just for a second.
You'll have to wait. I'm actually really done. If I type this in my calculator, it should be the last thing I'm doing. And I'm making a video right now, so they're listening to you talk. Do you want to tell all the people hi?
Hi.
Cool. Okay, so run along. Let me finish this, and I'll come into your room, okay?
Why do I have to run?
You can walk. Okay, so I'm going to, in my calculator, do 4 divided by 3 for 4/3 times 8, and I'm dividing that by 1.5625. Terrible decimal. It says near 100th of an inch, so my calculator is spitting out 6.82666666666666, but it says 100th, which is the 2. That 6 is going to round it up, so I'm going to say it's about 6.83 inches. So yeah, that one's a little unpleasant, but not unreasonable. The worst thing about it is we gave you some unpleasant numbers. If this shows up on like the SAT, I can pretty much be assured that they're not going to give you such non-rounding, not pleasant numbers. They probably give you something that divides by 3. In the future, maybe I'll get ambitious and update these notes, but that day is not today. So instead, wash your hands, because you're probably not doing anything right now other than just watching a math video. So go wash your hands. Maybe try some practice. Email your teacher if and when you have questions. If you can't find the button on your calculator, learn how Google works. But stay healthy, stay